So what is Java? Java is a popular cross-platform language. It's called an object-oriented language, meaning that it provides a way of reasoning about computational quantities in a way that uses, we call it encapsulation. It refers to them as treats them as objects which have state, which have some sort of properties about them and some current status that we can inquire about, and they have behavior. They evolve over time. Okay. AnyLogic is that a question? Yeah. Okay. So it's an object-oriented programming language introduced by Sun, now Oracle, now bought out by Oracle. But this notion of object-oriented turns out to be quite important for understanding many of the design decisions that are reflected in platforms such as AnyLogic. So yes, Carmen.
So, coming from a non-computer
Yeah.
science background, the terminology object-oriented doesn't really carry a lot of meaning to me still.
Sure.
It was on paper.
Yeah.
So, what preceded this, and how is object-oriented different? If
Right.
you can just summarize that in
Sure.
very lay terms.
Sure. We can, if we have a system like a model which goes complex, and we can break it up into, so generally when we build something like a model, we have to build it at pieces. Okay? You can't just build it in whole cloth as a completed monolithic thing, because too much complexity there. We have to use divide and conquer and build it in sub-pieces that we put together to make the whole thing. And it turns out that when we build up these systems, whether it's a simulation model or a larger system like, you know, what runs on your smartphone as an operating system like Android or Windows or what have you, we have to build it in, we have to figure out some way of building it up that's consistent. Kind of a sensible way of building it up. And there's two, there's many different ways to do this, but one way to do it, for example, that's older would be that you divide a system up according to operations done on data, and you would have, you know, some sort of central logic. It would call off to some component that would operate on something. It would call another procedure. It would operate on some other data. Call another procedure, operate on some other data. Call another procedure, operate on some data. And that data might consist of data, say, on many people. You know, rows of data, one row for each person or something. And you'd operate on that data in some way by calling off, say, like, age these people, and it would age each person in the population. Or you'd say, you know, make these people check if they're going to die in the next year. It would check that. And here, you know, what we would be doing is kind of, as we say, decomposing the system, sort of characterizing the system as composed of subpieces, which would operate across, say, all individuals in the population, performing one task at a time. I don't know if anyone in here has seen MATLAB. Has anyone? Okay. If you've done some work with MATLAB, you operate on arrays or vectors. And with those arrays, you know, you ask it to do, like, perform, add one to this array, or double this array, or add this array to that array, and that sort of thing, okay? And you can imagine simulating an agent-based, an individual level model like this. In other words, you could simulate an individual level model using characteristics of people where, let's suppose you have a person, each person has an income, a sex, an age, and a health status with respect to diabetes, something like that, okay? What you could do is, that's sort of, so here's, we might think of it in an object-oriented way. Okay, a person has an income. This is the way we've been looking at it today, a sex, an age, and a health status, which we might describe in something like AnyLogic with a state chart or something. But another way to describe this, and then we have many people who have these sort of characteristics, right? Another way to describe that is to have large vectors. So okay, this is the health status of the population. Health status for person 1, it's 3. For person 2, it's 1. For person 3, it's 5. This just encodes their health status. Another one would be the age of each population member. Would be 51, 25, 13, 98, and 27, or something like that. These would be the ages of population members. These would be the sexes of population members. Let's using the convention 0, 1, 0, 0, 1, 1, 1, 0, etc. So this is a way of describing the same population, right? The same information is there, and then we might have on each of these vectors a way of combining them in such a way that we operate upon them, in much the way you do with MATLAB. You might determine if people age, or which people die by giving it the age vector and the health status vector, and it spits back information about these people die, and then you remove their rows from these columns. And that would be okay to do, but it doesn't really recognize for us, it doesn't reify, as we say. It doesn't sort of represent as an entity a person, okay? Now here, in an agent-based model, like in object-oriented programming in general, what you're doing is you're grouping with the information about the person, like their properties that don't change, what we might call parameters, like their sex or their ethnicity, with parameters that do change, or things that do change, state that changes, income, age, and health status. We also associate their behavior, how their behavior evolves over time, and all of that is stored with person. And then we might have, a doctor, so we might have a person class that describes that sort of personhood and what these things mean, and then you would have a doctor class that has other characteristics like maybe, residency facility or maybe specialty, etc. And each doctor would have certain characteristics. And it turns out by doing this, for reasons we'll get into a Java tutorial later in the week, you get great economy of describing. For example, you say that, well, both patients and doctors are people, and therefore they share this certain set of attributes. Here, we're operating on sort of the people in the population, and almost like they're in a secondary way. They're just a person is just, to the degree we recognize a person as a quantity, it's kind of this row across all matrices or something along those lines. Excuse me, that row. And you could still perform the same operations this way. People do agent-based modeling in MATLAB. I've seen agent-based models in MATLAB. I've done agent-based models in Benson in this sort of way, where each person is essentially a row in several subsequent vectors of subscripted variables. But I wouldn't call it object-oriented. I wouldn't call it agent-based. Agent-based sort of has this very distinctive delineation that we treat our agents as sort of objects. They're self-contained things that have a state, properties, and that know how to evolve themselves over time. Does that make sense?
Yeah.
It's but fundamentally, when it comes down to it, you can perform the same basic simulation in an object-oriented way or not, in an agent-based way or just another individual-based way, a way that delineates, that captures individual level phenomenon. However, they will have trade-offs in terms of how easy they are to understand, how easy they are to visualize, how easy they are to manipulate in certain ways. One of the advantages of explicitly representing people as quantities is because often that lends an economy of sort of describing their behavior, which is helpful, but also it aids in understanding what's going on in a visualization sense, et cetera. It makes it easier to have that big picture of like how people are arranged in a network, which can be hard to get if they're just elements of arrays. And you have an array that represents their connectivity matrix. I've done that before, lived that, and I will tell you that you miss certain salient aspects of the dynamics when you do something like that, because certain things are just submerged, whereas depicting them as we do today in networks where the individuals evolve over time, that's much more helpful. Does that partly address?
Yeah, no, that's great.
Okay. I'm glad to talk more about that if they were interested at some point. Okay. So AnyLogic rides atop this language, Java. It turns your models into Java beneath the surface. And AnyLogic offers a lot of ways to insert snippets of Java code at many places in your model. In fact, much of what you think are just constants being entered into Java, into AnyLogic are in fact Java code. And they happen to be constant right now, but you could turn it into an expression, you could call off to a database, or what have you. Now, you'll need to grapple with this if you want to push envelope outside its normal typical support. If you want to exchange messages between agents, put in place specific initialization mechanisms, collect custom statistics. If you want to deal with performance issues, sometimes you want to have some awareness of sort of what's going on at the level of Java. What's the big deal about using Java for model development? It does confer some advantages because it's an extremely widely used language. Time was that Fortran was the #1 language in the world, and it's still very popular for dusty deck software. But I think Java is probably the #1 programming language in use in terms of the raw code base available today. There's huge variety of Java so-called libraries available. What that means is your AnyLogic model can make use of an absolutely fantastically large set of functionality that other people have contributed out there. You can make use of that to extend the functionality of your model, to make it richer, to spare you from work, etc. So for example, libraries to interface with external software, visualization tools, scientific computing tools, libraries to connect to databases, libraries to connect with live data feeds, all sorts of stuff. And then there's sets of tools such as that help in the modeling process, such as profilers to discover where performance is lagging, debuggers, tools like JUnit that help you test your model, etc. So let's talk about a little bit about this process where Java fits in. So what happens is that AnyLogic takes your model in a more declarative form, or you specify sort of using state charts, sort of what you want to be happening within the model, what the structure of the model is, and it turns it into Java code behind the scenes. Generally speaking, you don't have to look at this Java code. Occasionally it will stick its ugly head out and hit you, in which case you have to look at it, but you can't modify it. Modification is not possible. Why do I say it'll stick its ugly head out? Well, first of all, it is ugly. And second of all, it sometimes is, it'll pop up when it doesn't understand what you're trying to do. You've made a mistake in a bit of code you've inserted, and it'll sort of pop you up and say, I don't know how to make sense of this. It's rare. You'll have to look at it in all its fulsome glory, but occasionally you'll actually may want to look at it just to see what in the world is going on here. We don't spend a lot of time looking at it. So I've written hundreds of thousands of lines of code in my time, professional software development for much of my life. I don't mind looking at Java code, and I understand the Java code that's produced, but by and large, I don't tend to look at it much unless I absolutely need to, because so much can be dealt with at this higher level. There are people who will cast doubts on this, who will tell you, well, a platform such as AnyLogic, without having used it, they'll say, probably you end up just doing things in Java anyway. The truth is, as a software developer, I've done tons of stuff in Java, tons of stuff in Java outside of AnyLogic, tons of work in AnyLogic, and I find myself predominantly interfacing with models at this level. It is rare that I have to write big gobs of Java. Sometimes it happens. I have to write a scheduler once, a sort of appointment book type schedule once to deal with the needs of a clinic booking system and that sort of stuff. But even that was pretty modest amount of code. You do have to write some code for a custom model that you want to put together for little bits here and there, but it tends not to be that much. Okay? So it really is true that you can operate the vast majority of time at this level. And as a modeler, this makes a huge difference because I'm a software developer, I'm a software engineer, and I teach software engineering. But when I'm thinking as a modeler, I'd much prefer to operate at this level. It enhances my clarity of understanding of what's going on. I don't want to have to look at variable declarations, at sort of constructs in Java when I'm thinking as a modeler. Occasionally, I have to go down to this level to implement some custom functionality, and I will do that gladly. But generally speaking, you really can operate at this level, this declarative level, this level where we describe mostly what we want to happen, and it will take care of a great deal of what's needed. We just have to fill in some pieces. So yes.
Yeah, I just wanted to second what Dr. Osgood said. I mean, I literally use AnyLogic every single day. I've done nothing but build models in AnyLogic the last year. And I can tell you that the amount of Java coding you've done today is about what I do. I am not a software programmer. I'm an industrial engineer. I've had one Java class in my entire life. And not only can I build models in AnyLogic, I am the head technical person in North America for AnyLogic. So, if you guys want to, do I use Java code? Yes, but you've seen, the stuff you've seen today is about the extent of what I do in Java with Java. So, I'm not sure about that. We are accepting resumes for engineers. Trust me.
And if you want to move to Chicago.
My job is less in Java programming. It's more about simulation modeling. What you're learning here, that's what you need to know to do my job.
Yeah. However, folks, it is absolutely essential to realize that if you're going to do AnyLogic on a serious basis, and you're going to be investing your time in a model, it is very important that you either have someone on call that you can ask those questions about Java for from time to time, or you develop you invest some time in really learning in a substantive way some of these issues. You buy an introduction to Java book just to get yourself very, very comfortable when you need it. If you don't have someone on call. When I say someone on call, I don't mean they'll be needed every day, not at all. It probably won't be. But just like if you're an epidemiologist, you want that biostatistician on call to ask that occasional custom issue that comes up about how do I do this tricky thing, this is non-standard, doesn't fit into what I see in the textbooks. You want someone on call who can look into Java code and say, oh yeah, I know what's going on, you've got that certain situation.
Yeah, and for AnyLogic, that's our support people. I handle modeling support, but if you have a hardcore Java question, which you'll get maybe 1 or 2 a month, instance rate, you can contact our support people, and they'll say, you just give them the problem, and they will give you the answer. So very much so. We provide those.
We also, so our team here gets those occasional questions, so we'll get people who say, I hit a wall and I've been working with this. They built up a very large model over, many, many months, and now they've hit something which they just don't it is something where if you have the right person, it's a win-win. You know, it spares you a lot of time, it spares them a lot of, and they can do it very, very quickly and can help you out very effectively. So let's talk about this process. You take this model, and the vast, vast, vast majority of your time is spent. It really is true. You'll have some Java code in there that you'll probably put in. It tends to be quite small amounts. And occasionally you'll have to see this just to sort of deal with an issue or two if there's an error or if there's a performance thing. And what happens is AnyLogic turns it into this behind the scenes and then into what's called bytecode, which actually is the thing that can run within what's called a Java virtual machine. So it actually takes care of writing this. Now the advantage of having it in bytecode is it can run on a wide variety of machines, and it can link in with a large number of other sort of so-called libraries. So you'll find within AnyLogic there's this thing called a build button up at the top. You want to use that early, you want to use that often. That will help make sure that AnyLogic knows what you mean by the model. So there's two types of broad errors that will come up in this process. One error is that AnyLogic won't be able to go from here to here because it doesn't know what you mean. You've done something which flummoxes it. For example, you have a transition arrow that doesn't go anywhere. It just sticks out into space. Doesn't know why. I don't know what that means. Or you'll have, you know, a name of a state where you put an exclamation point as part of it, or you'll put a star as part of it. And it says, I don't know what to do with that. I don't know. I can't make heads or tails of that, and it freaks out a bit. That's one sort of error. And it will warn you about that when you do a build. A build is the process that goes from here all the way down to here. It'll try to make sense of your model. And to first do that, it has to study your model and say, okay, is everything sensible here? And sometimes silly things throw it off. Java is case sensitive, for example. You meant, you know, person with a capital P, and you actually put capital person with a lowercase p, and it will be unhappy. I don't know what you mean. I don't know, person with a lowercase p. All I know is one of the big P. Well, come on, it's the same person. But Java is picky. It takes you for your word. It allows you to have one with an uppercase, one with a lowercase, just like we saw with color today. And so sometimes little things get it. If you do a build, it will give you warnings that occur in this problems window. Okay. Alternatively, you can do a build up here by right-clicking and choosing build. This is where you'll see these things appear. So this is sort of when builds go bad, you have these errors cause here. So, you know, it doesn't know what to do with these problems. And you'll see that quite a bit. You want to attend to these problems. You want to go fix them when you see them. I might note you can also filter these things. So the only problems that are shown are from your class. So let me cause one of those problems. So let me do a build right now. And oh, look at that. I left normal in there. Okay, well, that's good. See, I had just started typing normal in just to demonstrate it. You may recall this. When I started typing it, I just left it there. It doesn't know what to do with it. It says, I don't know. It's looking for, it thinks it's a variable somewhere. And it says, you know, I don't know what to do. Normal cannot be resolved. You'll notice this is filtered. So what it's saying is only the thing that's actually selected, it will only show errors with respect to that. If I want to show all errors, it will show errors from other models, which I'm not particularly interested in right now. So I can filter it to show only mine. Generally speaking, I'd like to do it in an unfiltered way, so it shows me everything. So anyway, this is a case where it doesn't know what to do with that, and I can double click on it. It will take me to the place. For the most part. Occasionally it will take me to sort of the middle of the Java code where it sort of doesn't know what to do. If I put a star here, it'll be also an unhappy camper. So it'll say no cannot be resolved and ormal and rurmal cannot be resolved. So it doesn't know what to make of this star, and generally speaking, you can easily throw it off. Another example of an error, as I said, is if, let's suppose I had one of these transitions that goes off into space there, and it'll say hanging transition. That's a sign I need to fix something. Problems window is your friend. It may be it may be speaking truth to you in ways that leave you uncomfortable sometimes, but it will warn you about problems, and you really need to fix those problems. Yes.
Just
Scott.
want to add something else really quick on that. When you're resolving problems, resolve them one at a time.
Yep.
Every single time you resolve any problem, hit the build. The worst case I've ever had to deal with in one of my own models is I had one error. It was a semicolon where there was not supposed to be a semicolon, and it generated 23 errors in my model because it changed the entire reading of JavaScript and parser of the compiler. And so I fixed that one code, and all 23 issues disappeared.
Exactly.
So instead of saying, okay, what's this problem, what's this problem, what's this problem, fix them all, fix them one at a time because it, generally speaking, will resolve more than one issue. So.
That's exactly right. And part of the art of doing this efficiently is trying to figure out where the root problem might be. Sometimes it's the first, but it's not always the first. So what's the most basic problem in there? And sometimes you get into these cascades. I'm an old compiler guy myself, and so, you know, we write compilers, and they work great as long as things are going well, but once things get really weird, they start to, I don't know what's going on, I don't know, and they start to freak out and sort of just throw up their hands and say, I don't know what this is, I don't know what that is. Basically, they can't make sense of what you're saying once they start getting confused beyond a certain point. So you have to realize what you see as a cascade of things may just be one thing that we talked originally, or it may be two things interacting, but in ways that will allow it all to be fixed up. So I would generally suggest starting further up in the list, and I would suggest trying, as Scott said, fix and then build again. And generally you want to experiment. You want to try to fix things and see if it helps. Okay. A really good suggestion here, and I have a lecture on debugging, but I'm not positive we'll be able to do it, so I want to say it here. Ladies and gentlemen, one of the most important skills in working with computers, I don't care if you never see anyone again, one of the most important skills in working with computers is learning how to diagnose the causes of problems that you have. Okay? You could be working with Excel, and the same principle applies. You could be working with SQL database, the same issue applies. You could be working with R, and the same problem applies. Ladies and gentlemen, if your model is giving you big errors, it's giving you lots of problems now, and you can't solve it within a short period of time, one thing you can do will let you zero in. If you're getting really frustrated, save the model under a different name. Save it on model, model for debugging or something like that, and successively rip out pieces of it and see if the problem changes in a way that will give you a sense of where the issue is. So successively remove complexity for it. It will let you zero in on where the problem is. Why do I save that problem first? Because you don't want that to use that problem from then on. Once you locate the problem, then you go back and fix it and move on to get there. Okay. So save it to a separate name and rip out pieces until the problem either goes away or it's changed in such an obvious way you know where the problem is. That's why. Okay. So that problems window is your friend. It will pop up things and you've got to fix them. It alerts you to the fact that AnyLogic doesn't know what's going on, and you want to address those things. So I said that was one of the two things that happens wrong here. Those are the easy things. The harder problems are the problems which don't get detected. They make it through to here when the model's running, something goes wrong. These are problems which in general cannot be detected. Can you prove it? You cannot detect certain types of problems. Computers are extremely good at doing exactly what we tell them to do. But sometimes exactly what we tell them to do is not what we meant to tell them to do. We tell it to do something, we think we're telling one thing, we're actually telling it something that's subtly different, and it leads to a problem. So there will be problems which come up when the model's running that cause cause the model to not run anymore, as we say, the model to crash. And there's an art, ladies and gentlemen, to getting rid of those sort of problems, to debugging those sort of problems. And a lot of the same prescription, simplifying the model, saving it, simplifying by ripping out things, seeing if it solves the problems, simplify by turning things off, seeing if it solves the problems before ripping them out. These are really good prescriptions. I have a lecture on debugging. I'm planning on deepening it further. But the point is, there's a factor of 10 to 20 times in how quickly people can zero in an issue. And it's not so much whether you're a computer geek like me. It's an issue of whether you think systematically, you form hypotheses, you write down what you've done and what the results were, and you think seriously about what could be causing this. What did I change from when it used to work just 5 minutes ago till now that might have caused this issue? If you think systematically and you look for changes and you're systematic about removing or turning off parts, you can zero in the issue. Yes, Don?
Even worse than a runtime error, which is when your model crashes, is when the model doesn't crash and yet does not give you what you expect it to give you. This is incredibly, even a bigger issue in agent-based modeling because we have the issue, if you will, of emergent behavior. Sometimes what we get out of the model is what we should get out of the model, but when we programmed it, we don't recognize it as such. Other times, why isn't anyone switching state? The model won't crash. The model will keep running forever. But if I don't infect someone at the beginning, nothing's ever going to work in my model. That's the sort of conceptual, logical error that is actually the hardest to catch.
That's right.
I will also say in general, when you have an error that the compiler collects, which is the problems, if you double click on it, you will get almost always go to the graphical editor. But when a runtime error occurs and the model crashes, you'll get this big long line of code in the console saying this is what line threw the error. And when you go click on it, it will send you the Java code. So that's a little more of an issue.
We'll talk about that in a later Java tutorial and how you can use that information to zero in on where the problem is. Ladies and gentlemen, if you can learn to read just a few little issues, it's kind of like learning to listen for a few sounds about your car. So you can distinguish between a flat tire on the one hand from, distinguish that from an engine, getting on the fritz from a problem with the air conditioning. If you can kind of listen for a few things, learn to read a few things, you can much more quickly sort of zero in on where the problem might be. There's often it's staring you at the face if you just learn how to piece it apart. And I'll try to teach you how to do that, okay? But first I want to, bearing in mind the time here, we only have about a half an hour left, I want to talk about some basics that we talked about today. I introduced the notion today of a class. A class is kind of like a mold. It describes personness. It describes personhood, say. It's like a mold out of which we cast particular so-called objects, particular people, each of which has a specific income, sex, age, and health status. Then evolve over time, come into existence, go out of existence in a very flexible way. A way that would be hard to capture with arrays, in a truly dynamic population, people coming and going. It would lead to a lot of bookkeeping problems. So here we define a class when we design the model, so-called development time, and then there's lots of instances of it. We say there are instances of the class, these objects that are persons whose overall behavior, overall properties are kind of described by personhood, by this person class, but they circulate around at so-called, when the model's running, at so-called runtime. Okay, so I think I'm going to skip over here. We talked about this. Right, so what do we often do with these objects? I mean, when I say a person object, what do I do with that? Well, I can ask for information from it. I can ask for its age. I can ask for its sex. I can ask for its income, for example. I could maybe update one of those. I could call its methods. I could ask it for some information about itself. Say, what's your X location, or what's your Y location, or how many connections do you have? Or I could ask it to perform some task. I can tell it, okay, age yourself, or I could tell it, delete yourself or something along those lines. I could tell it, go put yourself in a database, that sort of thing. And finally, I can create those objects. So we saw a lot of this today. Like, if I have a reference to an agent, I can call get connections number, returns the number of connections. I could say, call your toString, gives a sort of representation of that agent as a string, so I could print out information on it. I could ask, give me all your connections. I could say, hey, connect to this other agent. So by saying one agent, I can address it. This is conceptually it's a command. I can say, hey, you connect to her, and now this connection. Or I could say, you disconnect from her. Or I could say, disconnect from all of your connections. Or I can ask for its connected agent. Remember we saw that in one of the examples. Or I could ask, is it connected to a particular agent? So all these are provided by AnyLogic as part of its standard standard support for the models. Okay. Another thing we will very frequently want to do is if we have an agent, let's say a person, we might want to say, hey, get me your associated name class. So I can ask something about the name class. Like I can ask how many people are in the population. So I can call a.getMain, and that will give me a reference to its main class. It lets me now then ask the main class questions, like how many people are in your population, or it may let me tell it, hey, remove this person from the population, or what have you. So the point is we can string things together by doing this. So we saw some things like this today. So I could say, if I have an agent, a reference to an agent, denoted by A, maybe it's this, maybe it's a is a variable that has a reference to an agent. I could say, get me your connected agent of 2. This is actually the third connected agent. They go 0, 1, 2, okay? And that will give me a reference, and then I could call its toString here, and it'll print out the name of the third agent to which A is connected, okay? Similarly, I can say A dot get, well, tell me what this does. Oh, man. Tell me what this does. What does that do? What's that? What does that do? Okay, so if I have a reference to A, for the first person to whom A is connected, it's getting that person's number of connections. So this is going to give me a number, 3. So A has some agent to whom it's connected. The very first agent to which it's connected, it's asking for that person's number of connections. Okay. Okay. I'm going to try to show you some an illustration of this in a sort of graphical fashion. So I mentioned before, objects in Java contain data of some sort. Fields, properties, some of these are state that evolve over time, some are fixed quantities, but those might be age, sex, ethnicity, health status, etc. And then there's some behavior, some sort of rules for how they evolve over time, like with a state chart, etc. So this might be an agent, for example, maybe field A is their their ethnicity, and field B is their age, or something like that. These objects, however, can contain reference to other objects. So maybe, for example, this particular agent has not only their ethnicity here, but also has a name associated with it, and has a reference to a different object which may represent, their mother or something like that. So here, for example, might be one agent, one person. They have an income, they have an age, they have a sex. And then they have people to whom they're connected. Maybe these people are their children, for example. Maybe one is their mother and the other two are their children, something like this. This is person C twice, so it should be person D. Sorry. So this person has a reference to these other persons. So if we were to take this and we were to ask this dot get connected agent of 0, it might refer to this person. so to the very first person to whom it's connected. If I call this dot get connected agent 1, it would say, hey, this, what's your first and the second person to whom you're connected, and return C. If I said this dot get connected agent 2, it would return a reference to D. It would give me back a reference to D. Just as this references this, it would give me back a reference to D that I could then ask further information, like what its name is, or how many connections it has, or what its age is, and all those sort of things. Alternatively, I could call this dot get main, and it will return a reference to the sole main object. There's a single main object that's circulating. And then I could ask from that, like, how many agents are in your population right now, and what time is it, and all those sort of things. Yeah. So, it's a good question. So if I am in, so if I have told this agent to do something, maybe it's calculate its income over the past 5 years, or maybe I tell it to have a child, or maybe I tell it to go and seek out a new friend. In the associated Java, this will refer to this agent, because that's the one that that's doing this work right now. Similarly, if I'm dealing with code in a state chart, remember in the state chart we have these transitions from like susceptible to infected? If I refer to this there, because that's located, that state chart is located in person, this refers to that particular person. So that state chart may be firing for 3 people at the same time. For each of them, they're going to have a this. It's going to refer to themselves. So there's going to be this for me, which refers to me. Kurt's this. Where is Kurt? Kurt's this is Kurt is okay. Kurt is outside the address space. Chenwei Chum. Chenwei Chum's this refers to himself. And if Chenwei Chum was operating, increased income method, which he'd probably not object to, his this would refer to himself. If I had my increased income method, to which I wouldn't also object, it would refer to me. So this is something that's defined, like when we're using code for an agent, say for a state chart, or stay in the dynamic property of the oval for the agent, it's referring to the agent. It's referring to this, the person in whom that's embedded. Does that make sense? Okay. Great question. So other questions about this? Literally. Okay. Okay. Well, so we have some. With this diagram, I hope it'll help you understand some of these relationships here and what's going on. So within our code, for example, this may refer to this, but if I say this dot get connected agent of 0, now I'm referring to another object, and if I say dot, get connections number, that will return the number of connections of this agent. If I said this dot get connected agent 1 dot get connections, I'm would refer to the number of persons connected with this particular person C. Does that make sense to people? Yes.
Does AnyLogic create person C with the same agent number each time? So if you're saying get connected to agent 1.
Yeah.
So.
Oh, I see.
Person C is agent 1 for that list.
I've listed them in this particular diagram, assuming that this is the order. So a given agent is going to have persons associated with it. And generally, the ordering of the persons to whom it's connected is not particularly significant, in the sense that, like all the things that we did would yield the same outcome, regardless of whether they were listed in this order or that order. So it's a somewhat arbitrary ordering. Like, for example, the fact that they were connected with their neighbors, it didn't matter which neighbor was first, second, or third. What mattered is that for each neighbor there was a line to it, right? It didn't matter if they had been in reverse order, there still would have been amongst the same two neighbors. They would have been handled in a different order, which one technically got drawn first. But generally, this ordering among the connections is not going to be material. I don't think I've ever written code where that I really pay attention to which order they're in. What is important is that you handle each of them in turn. Is that?
Call agent number two,
Yeah.
keep calling the same agent. It would keep referencing to that same
That's-
one,
that's
that
right.
particular seed of knowledge.
That's right. Yeah. So in other words, if we had a given person with some neighbors and we kept on calling get me connected agent number one, we would, unless something changed, unless he jettisoned a friend or something like that, we were expected to return keep on referring to person C. Does that make sense? Yeah. It's going to be very deterministic at that level. Now, eventually the agent might evolve and person P might die from the population, be eliminated from the population, in which case this would now become the first person to whom he's connected. But I'm just saying that over time things evolve. But if things weren't evolving in that sort of way, yeah, it would be very deterministic as to who's who. If you really want to do something very clear with this, like say have the mother be the first of all the people listed, you could do that. You just have to make sure the mother is, for example, never deleted from the population when she dies. And better yet, though, what I would really do is, the much better approach than that, is I would, instead of relying on AnyLogic sort of network to do it, I would just have a collection of children versus a variable to reference the mother within the agent. And I have a model, which I refer to here, ABM model with birth death, where you'll see exactly that sort of thing. There's a reference, for example, to my mother. So when I'm born, I have a reference to my mother, and when I give birth to a child, if I'm a female agent, I give birth to a child, then the baby has a reference to me that results as their mother. And so here we can kind of keep track of, okay, who's the mother. In fact, the same model has children in it, so it keeps track of your children over time. This is all in the model provided to you. So I think it has a list of children, and those children are kept track with over time. Okay. Just looking at this, right. So time is short here. Let me just see. Okay, I think we can actually do this. So we talked about get main. So suppose we have something that's a reference to a particular person. We said we could call get main to return a reference here. Now suppose we have a variable that is a reference to a person, to a particular person. So suppose we have one variable A and another variable B. Those are both references to people. They could refer to any number of different people. But suppose we said A equals B. What that means is that if A can contain references to people and B as well, then they're both pointing to the same person. They're both pointing to the same individual, okay? Perhaps, for example, one of them is used to set the income of that person. The other will now be able to observe the result of that change. So maybe one increases the income. So you say, my first connection's income is now double. And if their child, for example, if they have a reference to their mother, might see the mother's income is now doubled. So generally, I can have several references to the same underlying person, just like, if we were to each list our friends in this room, some of us would list the same person as our friend. And that's fine. We have just references to the same underlying person here. So this notion of references is quite important within Java. What you'll find is that if you have in Java or have in AnyLogic in general, quantities, let's say color, this is a reference to an instance of type color, okay? This is the class. It has objects that are particular colors, and this is a reference to that object. Similarly, this is a reference to the person. State chart is a reference, this name state chart is a reference to a state chart object and that I can ask questions. I could say like state chart dot is state active such and such. So these references are quite helpful to use sometimes, and together with AnyLogic's library, you can use them to get various sorts of information, and to query certain just query for certain values that you might want to print out or something. Anyway, these are some aspects of the use of references. We'll see them quite a bit more in the next few days. References provide us a way of gathering information from objects or requesting services from objects like do something or give me this information, calculate this information. That will be very, very useful for you in running your models, okay? I was going to talk about arrays, but we have a separate thing of collections later, so I think I'll leave that. So any questions about this that I can answer right now? I'd refer you to this model because you'll see actually some examples in there which actually perform some more significant things in, for example, adding individuals in to remember who are my children or who's my mother, and where a mother, when she gives birth, is associated with a child and that sort of thing. Any questions, though, about this? Okay, either not needing help or beyond help. So, yes, thank you. On the Java tutorials? Yeah, I need to get them up there. I apologize. I'm a bit behind on that. But yeah, I'll get them up there by tomorrow. Yeah. And then they can be copied to your phone. Indeed, yeah, that's right. Yeah, there's slides here, and in fact, there's videos of me with some of the board's voice. I might have done a better job explaining that. But I did, I think, last year have a great amount of time to discuss some of these example codes. This is a bit of Java code where I'm creating, for example, a reference called mother, which refers to, or a reference called offspring, refers to a person, which particular person refers to the baby that I've just delivered by adding it to the population. And then I, for example, print out information about the baby, and I add the baby to my connections as mother, etc. My children, list of children. Okay, so I think it's just about time for the first bus here. So those who'd like to take the first bus could do so. There'll be another bus in about 15 minutes. And I'd be glad to answer questions during that time if people have them. Okay? The bus should be downstairs in just a few minutes now. So I appreciate your patience today. It seemed, am I right in saying that some projects seem to be sort of coalescing? Could people maybe send me mail about projects or just be prepared to say something about it tomorrow morning? Yes.
What's the optimal size for a project? Because ours seems to be expanding exponentially. I'm kind of worried about it.
Yeah.
7 people coming in for 50 people and in the end.
Indeed. Well, from my experience with semester projects, 3 and 4 can make a lot of progress. Above that, you need to have, I think, a clear delineation of kind of responsibilities or sort of division of work, sort of how each of you is going. Because what you don't want to get is a situation where the coordination effort just ends up dominating, all the work you get done. So what you end up doing is the talking all the time.
So maybe that's 3% will be split into maybe 4 or 3.
Yeah, and maybe each take an alternative. Like you might say, we could do it this way, we could do it that way. Why don't we have each subgroup take a different tack and see which one, sort of pans out the best.
Yeah.
That would be an idea, and then you can merge back, halfway through, and then have a separate division if you wanted to. But in any case, I think having all 7 working at the same time on one thing is a little bit overwhelming.
If we know which is the smallest group, then we can break that group. So if me and somebody else work on off this group, we don't know who is the smallest number. Anybody who needs another member, who has no group, or everybody has 5 and more.
Yeah, is every group 5 or more? Yeah.
Yeah, well, if it's a small group, we can break the 7 of the law. So we can break off to be added to another smaller group.
Sure. Or I think what was being discussed was maybe subdividing with the same focus, the same topic.
I think
It just
your solution is best. We stick with 7, but then we have 2, 3.
right.
And then we come together like you're more interested in legislation. You may have tailored focus of that work.
That's right.
And then the other group has a more diverse focus.
Right. Right.
Talking about the same thing, because then when I sort of want to shoehorn attention, or whatever you want to call it, to a sort of consensus.
Yeah. So they focus on different subpieces of it, or different challenges of it. And this is a very important component, trying to sort of prototype out what would it look if we went this way, or how might we flesh out this component. And you might get ideas from cross-fertilize each other all the time. So, good. Okay. That's good. Other questions? Questions to talk about? Okay. Good. I'll remain around in case anyone wants to come up and talk with me for the next 15 minutes. Talk about things, but you're welcome to continue doing some things here, certainly until the next bus. And if people wanted to work beyond that, let me know. I might be able to look into how we do that. Thank you. Hi.
Thanks for today.
Oh, no.
I have a question for you. So my project wasn't a taker.
Okay.
So
Okay.
I'm just wondering, I
Yeah.
guess Saturday is the day to focus on
Yeah.
those types of projects, is that
Yeah.
right? Until then, you mentioned that there are some exercises.
Absolutely.
you could suggest?
Yes.
I would really appreciate that.
Sure. Yeah, no, I mean, we put a lot of effort into the exercises. So, so the deal is with your particular project, what I'm thinking is I'd like to recommend particular exercises. Let me just show you the general format of these exercises. What I'd like to do is to think a little bit more for your project about sort of which of them would speak most closely to sort of your specific interest. But generally speaking, we've all already kind of done this in class. And these sort of things are similar to what we did today.
Okay.
There's a version of this already available that that you could just use if you want to build a top of it. So let's see. With your case, you'd certainly probably want to do something with this. You want to get familiar with this process.
Yep.
This has some overlaps with what we were doing. This one also would be a useful one.
Yep.
Now, I don't know how much, you do have some data that you're trying to match, right?
Exactly, yeah.
So This one is going to be a stronger challenge, but I would suggest that you eventually do it,
Okay.
okay? Because you want to see sort of how you can get data out of this model in a way that might be comparable to actual data that you have at your disposal empirically.
Yes, yeah, that's right.
And so this one would also be quite appropriate. This one sort of captures two different populations, might be of interest. I don't know if are you looking at things through a multi-level lens at all, like,
Like nest.
yeah, nested
Yes.
category, okay, because if you're doing that, there's also some online material where I go through building up step by step a hierarchical model in AnyLogic. In other words, I build up, I think it's a model with cities, and each city has populations, but in your case it might be neighborhoods and neighborhoods of populations. And I would suggest that you go through that.
Okay.
That's a video, and I don't have it written down as an exercise yet, but I'd like to move in that direction. But the point is, if you did that, I think that will give you a good feel for sort of how you might build things up. But in terms of ordering this, what I would suggest is you look at these two and you see if you feel comfortable with them based on what we've done, and or if you want to exercise those things more. But what I'd also suggest, Brenda, is I mean, if you're interested in kind of pushing forward your conception of you know, like exploring some ideas, so that these exercises are sort of you know, just building up so that you can kind of take off on your own. I would like to suggest that a TA work with you.
Okay.
So this TA Kurt, did you see him?
Yes, I did.
He was sitting over
Is it
here.
green?
Yeah, I'm gonna ask him if that's okay to sort of be working with you enough so that he see if it's one TA who has some sort of more strong responsibility, then he'll be able to keep in mind your context and what you're trying to achieve. Where if there's different TAs, each time you'll have to explain some things. So I'm going to ask him to sort of take responsibility for sort of watching over you and helping you talk over some issues. And you know, he may be spending a fair bit of extra time on this project or that project, but I'll make sure that when you need it, you know, he can help push you forward. And what I'd like for you to do is to sort of look this over and basically figure out when if you want to try to push forward before doing this, or if you want to build your skills, because this will definitely reinforce the skills we saw today,
Okay.
sort of like basics,
Yeah.
and give you a leg up for doing what you're trying to do, which will be really helpful. This one, I would suggest leaving this for another day or two. But the hierarchical model, you could actually do, you could do that quite soon, okay? So you could do that in the next day and just be fine. This one will be a little bit more advanced, and it might be helpful for you to hear my calibration lecture first.
Yeah, that sounds
Okay?
good.
Okay, so I hope that's of
Very
help,
helpful. Yeah,
and
thank you.
I'll see if I can grab Kurt and let him know that he should watch out for you and try to meet with you on a regular basis to sort of help push this forward, make sure your questions get answered.
That would be wonderful.
Okay,
Thank you so
great.
much.
Hey, my pleasure. So long.
It's like if I run a feed, they think it's